Hey guys. All right. So last week we were learning, I just introduced the periodic table of elements. Today we're going to go into how the periodic table of elements is arranged. Hopefully you remember the name of the guy, Dmitri Mendeleev. He was the chemist, alchemist back in the 1860s, 1870s, who had first started to arrange the periodic table. Each one of the elements on the periodic table has its own unique number of protons, neutrons, and electrons. Remember from the last couple weeks, if you see my shirt here, never trust an atom. They make up everything. And it's because every single thing on Earth, everything you see back here in this camera is made up of an element or a combination of elements that come off of this periodic table. Dmitri Mendeleev only knew of 65 elements back in the late 1800s. However, they had figured out what the atomic mass, or we think of mass as weight here on Earth, he had figured out what the atomic mass was of each of those atoms. So his very first arrangement of the periodic table, he arranged it according to atomic mass. Nowadays, we know that we arrange the periodic table by the atomic number. And the atomic number is the number of protons in the atom. The atomic mass is the weight of the protons plus the neutrons. Okay, so here's his periodic table. So we have, going across the periodic table, we have 18 groups, okay, 18 columns going up and down. And these columns are known as groups, and there's 18 of them. Each group has its own unique set of properties. If we start at the top of a group, and I'm going to look at group number 1 here, you can look at page 84 and 85 in your textbook, or you can go to the laminated periodic table that you should have at home. If I take a look at group 1 here, these are reactive metals. I'm going to take a look at the very first one right here. Well, it's not the top one, hydrogen is, but I'm going to drop below that to lithium. Lithium is a metal that reacts when it is exposed to oxygen. It actually catches on fire. And I've got a series of videos in the PowerPoint that's on my class page that shows you what lithium does when it's exposed to air. Right below it is another metal called sodium. Sodium has the same reaction as lithium. However, it is more reactive, which when we're talking about an explosion or catching on fire means boom, a bigger boom. As we move down that group, potassium, rubidium, cesium, and eventually francium, these metals going down the group become more reactive. So check out those videos on that PowerPoint. So groups go down, there's 18 of them as you move across the chart. The other thing is moving this way. These are called periods. Let's see if it'll stay on there. Can you see it? Oh, you can see it. All right, these are called periods going across. And we only have 7 periods on the periodic table. And as you go across the periods, you find that it's increasing by 1 proton. Each time you head to the right, 1 more proton has been added onto that. Now, each one of these tiles or each one of these elements, I've got one that I'm going to bring up close here. This tile is potassium. And on the top, we've got the number 19. So if you go to your periodic table, number 19 is going to be found in group 1, period 4. It's right here. It's kind of like a battleship, you know. If you've ever played Battleship, you're working with your x-axis and your y-axis to pinpoint where something is. That's how the periodic table works. If I say go to group 8, period 7, I'm working way down with this borium. Okay, so I've got number 19. The number 19 tells us that there are 19 protons in that atom. Last week's lesson told us that if we want our atom to have a neutral charge, those 19 positive protons have to have 19 negatively charged electrons to offset it. The other things found on this tile, this is the element's name, potassium, but its symbol is the letter K. Why? Well, that would be a great extra credit bonus question for you to send me the answer to. Why does potassium have the letter K? You would think it would be the letter P, but the letter P ends up being another element called phosphorus. And then the number down below that you find at the bottom of the tiles is the atomic mass. And if you remember from last week's PhET exercise, the mass of an atom comes from adding the protons and the neutrally charged neutrons. So whatever's in the nucleus of the atom is what gives us the potassium, is what gives us the atomic mass. Now I could do a little bit of math here and I could subtract those two numbers and it would tell me exactly how many neutrons. So this is pretty close to 40. Well, no, I would probably leave it at 39. Never mind. It wouldn't round up to 40. But if I subtract those two, okay, that's going to leave me with 20. And so that's how many neutrons I would have in this atom. So for this week, you're going to do some reading in your textbook, pages, I believe it was 80 to 87. It's going to review this idea of groups and periods. It's also going to take a little look at each tile, the atomic number, the atomic mass, the symbol, and the name of the element. I want you to review those because before we can go on and start to break this up into metals, nonmetals, acids, and bases, I got to make sure that you know groups and periods. Okay. Hey, have a good week. And remember to stop in for my lesson and for some office hours. Bye-bye.